Hello and welcome to the sixth session of Java video series. In this session, we will understand about arrays in Java. Consider an example where I need to declare 100 variables of int type. So to declare 100 variables of type int, what I can do is there's the text document. I can write down like int x1, the smallest possible way to declare 100 possible variables. So this variable actually this is not a declaration of 100 variables, but consider this that it starts from x1, then x2 and x3 and so on and so forth till it reaches x100. In this way we can write down 100 variables of type int. And the next step is that I want to print out all the variables which I have declared onto screen to know the values associated with each of the variables available. So what I have to do is I have to each time write down the printing statement and change the variable and so on and so forth till 100th value, right? As you can see that when I write down the code, while writing down the code, that it only requires about 100 lines of code to show all the variables available in the program. Also, it's very easy to display all the variables using a single statement, but you can see that the length of the code will be increased substantially. And when the length of the code increases, the efficiency of the code decreases. Also, maintainability of the code decreases and readability of the code is decreased as well. Besides, there is problem in accessing the content of each and every variable present inside the program. So keeping these problems in mind, Sun Microsystem decided to introduce a new concept which is called an array. So array has been given the ability to define lots of variables under the same name. We can have different elements inside an array, or we can say that we can have different elements inside one or under one name. So that particular name is the name of the array. And there is another thing known as indices that are associated with arrays. So with the help of indices we can access all the elements related to the arrays. So to declare array, basically there is an int. For example, I want to declare array of int type, so I write down int and then I will choose an appropriate name. So say x1 is an appropriate name, or say an array is an appropriate name, and because it qualifies all the identifiers rules. So and then we try to give it some more syntax which we will be discussing, and then through that we can access all the elements present inside array. So one thing is that we can have 100 variables under one name using array. If we see this problem in a bigger context, we will see that we can have thousands of elements of the same kind. Say for example, if I have an organization and I want to display salary of my employees inside organization, then an organization can have thousands of employees associated with them, and in order to do so I will if there is no concept of array, then I would have to declare 1,000 types of variables for that, and that would have been a real tedious task for me. But after the introduction of arrays in Java, that task can be done under single variable name. Now let's move on further with the topic and see what actually is the definition of an array. So before really going through this definition of array, what are the agendas in this session? So first agenda we are going to discuss is introduction, which I have already given to you. Then array declaration, how we can declare an array inside Java, and then array creation. These are the three topics which we are going to discuss in this session. In the next sessions, we will be discussing about array initialization, array declaration, creation and initialization in a single line. And then length versus length. Length here is a variable name and length over here is a method because it is suffixed with two brackets. So if there are two brackets like this, then it means that this is a method name, and if there are no brackets available with the name, then it means it's a variable name. It has some particular meaning that we will be discussing very soon or in the next video sessions. Then anonymous arrays, and then array elements assignments, followed by array variable assignments. This will be the whole agenda related to the arrays inside Java. We will be discussing a lot about arrays, so it's going to be a large session. So let's begin with the simple definition of array. Before really going through the definition once again, I would like to tell that arrays are the concept which contains only homogeneous types of data. It means we cannot use, for example, I want to use salary, then in the next instance I cannot use the same array for declaring the name. What does that mean is, if I want to use the salary type of data, then I have to use the salary type of data in that array. So it's a homogeneous type of data that can be stored inside the array. Besides, there is also another limitation associated with array, which states that we want to know the size of the array or the elements which are to be inside array in advance. This can be understood by the fact that, say, if I have an organization and I want to declare an array for my organization's employee, then I must know the number of employees that are working under that organization so that I can declare that array. Why such a constraint is available with the array inside Java is due to the fact that array size cannot be increased or decreased once they are declared inside the program. So let's see the definition of arrays. So definition of array says an array is an index collection of fixed number of homogeneous data elements. So it's a fixed number of homogeneous data elements. Homogeneous data elements means the type of the array or the elements that are going to be inside the array should be homogeneous. It means if the type of array is int, then the data elements that can reside inside that kind of array is an int. And then it is fixed number, so we should know priorly the size of the array. Afterwards, it says it's an index collection. So what basically an index is? Through the help of index, we can access the elements inside the array. So say if I have one element or the first element of the array, then if I have to access that particular element or the first element of the array, then I have to use the index 0. So it means the first element of the array has an index 0. How to access or how to write down the index in terms of syntax is what we will be discussing very soon. But for now, the first element has index 0 and the second element will have index as 1 and so on and so forth. So the nth element in the array list will have index n minus 1. The main advantage of arrays is we can represent huge number of values by using single variable, so that readability of the code will be improved. Besides that, maintainability of the code becomes also easy, right? And the main disadvantage of arrays is fixed size. That is, once we create an array, there is no chance of increasing or decreasing based on our requirement. Hence, to use arrays, we should know the size in advance, which is not possible always. So this is a very dangerous point. We should know the size in advance, right? Now comes the topic of array declaration. One-dimensional array declaration. So let's start with the basic array declaration. We will be talking about one-dimensional array declaration. So this is the second point which we will be discussing, but at this point let's talk about the first point over here, one-dimensional array declaration. So according to one-dimensional array declaration, say I have a test over here, right? I have this example, 1D array declaration. So it states that I can write down the type of the array, right? Say I want to have elements of type int. For example, if I want to declare the salaries of the employees, then I have to use int data type, right? Or if I want to display the phone numbers, then I have to use int data type. So int is one type, and if I want to tell the compiler that I am dealing with the arrays, then I have to put square brackets like this, an opening and closing square brackets simultaneously, right? So it tells the compiler that okay, this is not a simple or one int variable, it is actually an array. It's an array of int, right? And the name of that array is x. So it's declared to the compiler that we are going to use x as an array of int. So this type of declaration is recommended because name is clearly separated from the type, right? So this form of declaration is recommended. What it says, x is of type array of int, right? These two types are also fine to write. Their syntax is right, they're syntactically right, so there's no problem in this declaration as well, but this one is recommended. Now let's see that all these three declarations are right. So let's close this one, I don't want to save it, and then go to test the program that I want to compile. So let's simply paste it and let's remove this one as well. Now edit the program a little bit so that it should look clear. Okay, that's okay. Now saving the code, because if I want to reflect the changes which are there inside the code, then I must save the code and compile it each time, because the name of the program is test, that's why test.java here. Now program is compiled, it's going to give me an error. Of course it's going to give the error because I have not changed the name. It's going to give the duplicacy error of related to the naming. So after changing the name, please save the code and compile, and we will see that there is still one error. Why? Because okay, this is not a correct name, because correct name is this, right? I'm sorry, my bad. So let's once again copy this and paste it, save, and you see that there is no error related to the declaration. So that is how we can declare the one-dimensional arrays. Now next point says that at the time of declaration we cannot specify the size, otherwise we will get compile time error. So when we are declaring arrays, then we should not declare the size at that time, because compiler is going to flag error at that time. In case of C, we can declare the size of the array while declaring it, but in case of Java it is not possible. The compiler is going to flag the error. So say if I want to where is the program? Yeah, if I want to I'm sorry, let me just remove these extra windows so that it becomes easier for me to look onto the matter, right? So this is one, right? So say if I want to specify the size, then I have already mentioned over here that it is false and this one is true. So if I copy this program into the test pad, I will find that the first declaration is wrong. But before that, let me change the name so that there is no duplicacy of name error. So according to the rule, this is the declaration of the size of the array. It means according to us that the array should contain 6 elements and index starting from 0, so ending up to 5 and going up to 5. So basically it's wrong because the Java compiler does not allow this. How to specify the size we will be discussing very soon, but for now let's compile the program once again, because I have changed the code and see the errors related. So errors are Java C test.java, right? So this is an error, so this is not correct. So if I comment this line out, it means this is right. We have already seen this in our code previously, so this is perfectly okay. But the declaration of the size of the array is not the valid point, right? So this being said, let's move on to the two-dimensional array declaration. So how to declare two-dimensional array declaration, right? To declare two-dimensional arrays, what we can do is, right, cool. So two-dimensional array declaration is also very easy. For declaring one-dimensional array, we are using one pair of square brackets, right? For declaring two-dimensional array, we are using two pairs of square brackets, opening, and closing, right? So the recommended one is the first one because the readability of the code is good. X is two-dimensional array of type int. So first one is recommended because the readability is important in case of long codes. Second one is also right, only the position of the two square brackets have changed from int towards x. I've already changed the name over here, right? And in the third case, we have the square brackets moving to the right of the variable name, right? And the fourth case, we have one square bracket near int or the keyword and the other square bracket near the variable name, like this. And the fourth case, we have one square bracket near int and the other one on the right side of the variable name, like this. So in the previous case it was on the left side, in this case it's on the right side. And in the last case, we have all the square brackets available with the variable name but to the right and to the left. And this is also a very valid declaration. So all these 6 are valid declarations. So if we want to declare, only declare, right, the integer array of 2 dimensions, then what we can do is we can use this format in any of the above 6 available options. And when we try to compile it, we will see that it's right, because all the above declarations contains different variable names, so it's perfectly all right, and all the above declarations are valid as well. Again, moving on to the next point, if we want to specify dimensions before the variables, that facility, okay, dimension means the size, right? So if we want to specify the size before the variables, right, x1, x2, x3 are the variables, that facility is applicable only for first variable, right? So say I have an int x comma y comma z, it means x, y, z are of type int. Similarly, int and then array, right, and then x, y, z means I have arrays of type x, y and z, right? So if we want to specify dimensions before the variable, so that facility is applicable only for first variable in the declaration. So to understand this point better, let me go back to first question over here, right? Before really going through that point, let us do this question: which of the following are valid? So if we see through the figure, we find that int array, so it's one dimensional, right? And a is one dimensional, b is also one dimensional, right? So this declaration is very much readable. A and b are one dimensional arrays of type int, right? A and b of type array int of one dimension. Now in the second declaration, we have a square bracket available with a variable, and then there is this bracket which is also available with b, but there's also a bracket available with a, so a becomes twice and b is 1. So a is a 2D whereas b is a 1D array, right? 1D, d for dimension, right? So a is 2D and b is 1D array. In the third case, we have one over here and one over here, so it becomes 2D, and with b we also have another one, so a and b both are 2Ds. In the third case, we have, this is a tricky question. I would like you to hide all the answers from your screen by putting a hand on it and then try to answer all the questions to have a practice of the same, right? So this is an array near int. This is also a sign of array, square brackets, which is near variable name. I can really separate this from A and put it over here, right? So now that becomes 2D, as we have seen that we can declare it like this and this, right? So this type is like X3 type over here. So A and B both are two-dimensional in this case. I hope I'm clear. Now coming to the next question. This is two-dimensional array. So A is two-dimensional, but B contains another one. So B is three-dimensional, right? So that's how we find. Although I will not be discussing about the outputs here, but we will be discussing about this question once again in the later video sessions when we will be discussing about length and how many elements are there inside the array. So let's move on to the next question. Int array, it's a 2D array, right? Again from the same point, because this is a 2D array, so this is also a 2D array, right? So A is 2D and B is 3D. So what basically has gone wrong is that we are specifying the description of array before variable name in the second instance, right? This is not allowed in Java. The description of the arrays in case of B over here is allowed in Java, in which we have only two arrays, right? A and B, two arrays. So this is allowed. Whereas in the last case, we have a description of B's array where square brackets are coming before B. So this is not allowed. And if I try to compile this program, I will find that indeed this is wrong, right? I cannot find this size for now for you, but let me run this one, the last one for you in the code. So it should give me an error, right? And I will be running the second last one as well, so that it becomes clear that this one is not allowed. This type of declaration is not allowed. But say if I move down the square brackets to the right hand side, saving the code once again, and then trying to recompile to see, okay, and it says it's perfectly all right. So my point is very much valid, right? So let's do the next example. It says we have array 2D array. A is a 2D array, but in case of B we have square brackets before B, which is a second instance, and it is not allowed in case of second instance and onwards. So B is wrong declaration and C is also wrong declaration. So say if I copy this code and go back to the test file, paste it over there, saving the code, and then going back to the file and then trying to compile again, we find 4 errors, right? We're not concerned about the message inside the errors, but let me change the position over here for C from the left side to the right hand side of C, for B from left hand side to the right hand side of the same. Let me check if this is right, and when I try to compile it, it compiles fine. So it means the same code is fine. Say now if I try to replace the square brackets from right to left once again in C, then it again should give me an errors. In the first case we got 4 errors, right? 2 errors were associated with B and 2 were associated with C. In the last case we got 2 errors. So it means A and B were correct, but C was having some problem. So this is not allowed at all. So this is the point related to the second point. If we want to specify dimensions before the variables, that facility is applicable only for first variable in the declaration. So I hope my point is very much clear. Next point states if we are trying to apply for next variable onward, right? If you are trying to apply for next variable onward, we will get compile time error. All right, we have discussed this. And the next point is 3-dimensional array declaration. As you might have guessed it by now. I'm sorry. Let me run this one once again. Yeah, 3-dimensional array declaration, and then let's see the examples related to it. So 3-dimensional array, 3 square brackets. This is the recommended one, right? A is a 3-dimensional array of type int. That's the way how to read it, or you can have your own way, which should sound correct. And we can replace or readjust the square brackets like this, or like this to the right hand side of variable, or we can have separations like this or like this or like this, right? Each and every declaration over here that is present inside this figure is absolutely right. So if I try to compile this program, it should not give me error. Of course, I have to change the names over here. So let me change the name over here from A1 to A2 and then to A3, over here to A4. Maybe I should not do this, but let me do it and see if I get any kind of error related to the declaration, although the point states that I should not, and it's perfectly alright, right? So that being said, let's see the question. Okay, next we are going to discuss about the array creation. So that was about three-dimensional array declaration. Now array creation, one-dimensional array creation. Okay, so when we talk about the one-dimensional array creation, we have already seen the example. So that's the part of the declaration. After declaring the array, what we have to do is we have to put an equal sign, right? And then write new keyword. New is used to create objects, and we know that from previous sessions that array is an object. So new is used in case of arrays as well. So then we write new, and then we write the type of array which we have mentioned in our declaration on the right hand side, and then we write the square bracket, opening square bracket, and then we specify the size that we want to associate with the array, right? And then we close this brackets, and then we put a semicolon. So in this way we have declared an array A, right, whose size is 3. We have created an array of type int whose size is 3. So let me compile this one and see to it that this is indeed a valid declaration. When I compile this one, I find no error. Perfectly alright. So this is the way to create an array. How to prove that exactly 3 array elements are created inside array is the part of length versus length. We will be discussing about that in the later video sessions. For now, let's move on to the next point. So we have looked at the creation of one-dimensional arrays. Now every array in Java is an object only, hence we can create arrays by using new operator. We have discussed already. For every array type, corresponding classes are available, and these classes are part of Java language, right? So say I have one-dimensional array, then there will be a class available with Java which handles the one-dimensional arrays related to int, if I am declaring the array of type int. Then if I have a one-dimensional array related to characters, then there will be a class which is present inside Java which will be handling one-dimensional arrays related to character. And these classes which are handling the array dimensions are not available at the programming level. It means we cannot change them or we cannot use them. They are only available to us to assist us in array creation and their declaration and initialization, etc. But at the programming language where we can manipulate those classes is not in our range. So int a equals to new int 3, right? This is the creation of one-dimensional array which consists of 3 elements inside it. Now I want to get the name associated with the variable a, because a is one-dimensional, then it should give me some kind of array name class, right? So how to get that? Say I want to print it onto the screen, then I will use the object. It's an object because I have used new, right? So a dot, and I can call methods on object, right? So a dot get class. So with which class this is associated will be available to this much portion, right? I'm sorry, this much portion. After this, after getting the class, what I want to know is, say you got the person over here, and then here you got the name of the person, right? So you got the person or you got the class over here, and here you got the name of the class. So a dot get class dot get name. So first a dot get class will be called, and then after getting the class you will get the name. So the name of the class will be like an opening square bracket followed by an uppercase I, square bracket and capital letter I, as I have mentioned already. So this is the way you can get the class name associated with the arrays. And to prove this point further, let me copy this one and show to you that indeed the output will be like what I am talking. So this is compiled fine, so there is no error, and then I try to run it and I'll find that this is an opening square bracket and an uppercase letter I over here. After completing this point, let's move on to the next point, which states that at the time of array creation, when we create array, we must specify the size. So on the new parts on the right hand side, or the new operator part, we must specify the size inside the square brackets, else we will get compile time. And to prove further this point, let's see if we have any kind of example. Okay, we have one more example related to getting the class name. That is very important. I missed it. Let me discuss this one more time, then we will be discussing that point we have read. So I have declared an array of 2D integer type, array of 2 dimensions. Name of array is A, right? So A is a 2-dimensional array of type int. That's the way to read it. And then I have created it because a array is an object, that's why I have used new. And then I have to use the same type after new according to syntax, and then I can specify the size inside the square brackets. So because this is a 2-dimensional array, I have to have 2 square brackets over here, right? So I have specified 3 and 2. So it will be a 3 by 2 type of 2D array. Although it's an array in Java is never represented in matrix form or in tabular form. That's a different concept. We will be discussing that very soon. But for now, our concern is to get the class associated with A. So according to the figure, we have a.getClass. So you got the person, right, concerned, and you want to have the name of the person, you got the getName. So after getting the name, the output would be like 2 square brackets, opening square brackets, and then a capital letter I. That means if I have 1-dimensional array, I have 1 square bracket. If it is an int, I have a capital I related to it. If it's a 2-dimensional array, I will have 2 opening square brackets, and if it is an int, once again, then I will have a capital I. It means if I generalize the rule and do some logic, I'll find that if there is a character over here or char over here, then I should get a capital C over here, right? And if there is a char over here, then I will get a C again over here, capital C over here. So let's move on with the point and try to compile and see the outputs that will be coming after running this code out. So Control V and saving the code, and then quickly coming to the compilation screen, and we find that code compiles fine, and then running we got the same error, same message as expected. Now I try to change the array type from int to char. On changing the same from int to char, rest of the code will be same because there is no change in other respects. So let me just quickly compile this once again because I have changed the code. So, and those changes to appear, we must have to recompile it. What we are seeing is a C over here in place of I, right? Now say if I want to have about boolean, then we have to replace the same with boolean, right? And if I want to have about, for byte, then I will have to have it for like byte for as well. Now changing the names over here once again, and I can see that I have a name starting with B and B. So what will be the class name? When I have an int, then I was getting I. When I have a char, I was getting a C. But now here we have a B over there and B in byte case as well. So let's quickly save and compile and see what are the expected letters that will be coming so that we can memorize this. So we have an error over, right, because the name of the array is same. Okay, I have saved the name and I have to change the same over here, right, so that the changes should appear in the program as well. See, every minute detail is checked by the compiler. Code compiles successfully, and when we write, we see for what, for a is of type boolean. So for boolean we have a z, right, and for byte we have b. So byte kept being, and for boolean z was given, right. So this was another point related to arrays. So at the time of array creation we must specify the size. So okay, let's move on to the next point related to this, which was, yeah, if we do not specify the size at that time, we will get error. So let's quickly run that example in which we can declare, int a equals new int, and say I do not specify the size over there, so I must get an error there in this case. The rest of the syntax is same. This is declaration and this is creation using new operator. Int is matched only in the square brackets. I'm not specifying the size. After saving the same, when we go into the compilation scene, we will find the error stating that array dimension is missing, right? And if I specify the array dimension as say 4 and save the code, then I'll find that the same code is now happily running fine. Now let's move on to the next point. It is legal to have an array size 0. Wow. So it's perfectly alright to have an array size of 0. And to prove this point further, let's, instead of having 4 in this size window, let's take 0 and quickly saving and compiling the program, and we'll find that there is no error. To prove my point further, let me take a println statement so that it becomes clear that I have correctly saved and changed my code, and I'm not running the same code again and again over and over. So that is all right, and then I can see a 0 over here, right, which is, it's the specification in this println statement. So that statement is perfectly all right. Now what we would like to do is we would like to check for negative as well. Say I take negative of 1 and then I save it, because 0 is applicable, so 1 will definitely be applicable. But let's check out the negative size of array. So after quickly saving the code, we'll be coming back to the command prompt and try to compile, and we see that there is no error. So basically what we find that it's just the integer they are concerned about, right? And then I try to run the same, and there is the runtime error saying negative array size exception, right? So it didn't accept the size of the array as negative. At runtime it's going to give an error, or it's going to raise an exception in thread main, right? Let's consider further point by giving it a double or a float type of value, then compiling once again, and we will see that it's giving the right value. No, it's not compiling at all now. So what it says that it's possible loss of precision. Why? Because it required an int. So it means the value that is required inside the array declaration should be, array creation should be an int type. So required is int, whereas found is double, right? So we cannot use 1.5 or the double type or float type of values. We can use negative values up to compile time, but when it comes to runtime, it's gonna give us error. So it's not recommended to use negative values inside the code. This was the next point related to the arrays. So if we are trying to specify array size with some negative int value, then we will get a runtime exception, right? We have already seen this point. To specify array size, the allowed data types are byte, short, char, int. We have seen that there is no way we can specify float and double to it, and negative size is also not accepted during runtime, but the restriction goes to byte, short, char, int. Long was not given the same. Even long was not given the opportunity, right? So let's quickly see that integer is allowed. So if I want to specify a, as the size. So am I getting the same or not? Let me quickly change the printf statement so that the changes reflected should be there. So I should get an A in this case, and I am getting an A, right? So A is accepted perfectly. After this compiles fine, this is executed. That's why I'm saying that this is perfectly all right with the compiler. There is no runtime as well as compile time error we have seen from the command prompt, right? And after this, let's quickly see if long type of value is accepted. I hope we are going to get the loss of precision error. So let's check if I'm getting the loss of precision error over my screen, and we see, yeah, possible loss of precision error expected because long is found and int is required. Besides that, int is not capable of representing long. So if it's not capable of representing long, then it should be capable of having size of 21, 47, 48, 36 and 47. So this much size be applicable or be valid for int type, because int is applicable and the maximum values related to int is 21, 47, 48. So it's perfectly all right to have this, and if I run this, I will find an L. Why? I didn't want out of memory, right. It's a very, very much expected error. Please remember this error, out of memory error. Although at compile time we didn't get any error, and it's a type int, right? It's a type int, but we are not able to run our program successfully, right? This is one point. And say, to prove my point that it is indeed the last range, or it's the final maximum, it was the last range, I take one more integer in the array declaration, and I'll find that it's going to say that integer number 2 large, or some kind of error I'm going to get, hopefully, and it's error, right? Integer number 2 large, right? So that was the last range. 47 was the last range which was compiled successfully over here, but when we tried to run, we got the out of memory error. So to specify the point further, the maximum allowed array size in Java is this, which is the maximum value of int data type, right? But 2147483647 is the allowed data type. But if we try to specify, these are some examples we are going to discuss shortly, right? If we try to specify a size more than that, we are going to get the error false, right? Even in the first case, as I have explained, and as I have mentioned over in my notes as well, we may get runtime exception if sufficient heap memory not available. So we got the error stating out of memory error, right? So in the first case, although it is valid, it may get runtime exception. So that we have seen. Now let's talk about the remaining, this example. We have this is true because this is a declaration part, and this is in creation part, in which we are trying to create 10 elements of type int. It's a 1D array. The syntax is perfectly alright, so this is true. Now we are trying to create another array with 8. It's also true. We have declared byte b equals to 10, and then we are trying to assign it to b. This is also true because b is given the value 10 over here, and it's perfectly alright to have 10. Short s is equals to 20, and this is also true, but this is false. We have already seen this example over there. So this being done, let's talk about the creating an array which is having difference of 2 int arrays. The next topic says two-dimensional array creation, right? So we'll be talking about the two-dimensional array creation. Example includes, we have two-dimensional array declaration. X is a two-dimensional array of type int. Then we have a new and then int according to syntax, and then we are having the first dimensions specified with the size, but the second dimension is not there with the size. So we can create an array with the first dimension having its size, and we can leave the second pair of brackets empty in case of size. It's perfectly alright with the compiler. So this is right or true way of creation. And what does that basically mean? It means that I have an array which is having 2 elements inside it, and these 2 elements, okay, I am not able to show the figure over here, but consider that I am drawing 2 elements, right? Then the first element is going to point to one array of type 1D, and the second element is also going to point to another array of type 1D. So 2D array, and each element is going to point to 1D array, right, of the same type, of type int. So x0 is the first element of the 2D array, right, because x is the name of the 2D array. So x0 will be the name of the first element. Indices starts from 0, that's why, and name of the array is x. So indices with the array names gives the element. So the first element is having 1D array, and that 1D array contains two elements, right? So if we visualize, we will see that one element is going to point to two other elements of a one-dimensional array, right? And second, in this case, is second element is x1, because index of the second element is 1. So x1 is new in 3. It means the second element is going to point to three elements of one-dimensional array, right? So array elements can be accessed using index. 0th index means first element, first index means second, and so on, right? So x0 is the first 1D array and x1 is the second 1D array. x0 contains 1D array with 2 int numbers, and x1 contains the second array with 3 int numbers. Oh, there is no figure, I'm sorry. Let me see if I have created any kind of figure. In Java, 2D array is not implemented by using matrix style, as I have already told you. Sun followed array of arrays approach, right? Array of arrays approach, as we have discussed, an array, and then the elements are also pointing to the arrays. So that's why it's not a matrix style. Matrix style contains similar number, or at least some kind of 2 into 3 or 2 into 2, but there, in that case you can have multiple elements, or 5, 6, or odd number of elements available to you, which is not the case with matrix style. So Sun followed array of arrays approach for multi-dimensional creation, and from the example which we have discussed in the figure, we can see that we have the declaration of two-dimensional arrays, and in the first case we have an array which is having two elements, and the first element x0 is having an address of 1D array which is having two elements over here, and in case of the second element of the x of the two-dimensional array, in this case having the address of 1D array which contains three elements, like this. So this point being said, let's move on to the next point, which states the main advantage of this approach is memory utilization will be improved. Of course, there will be no loss of memory. Say if we have created, or if we have implemented the way of matrix style, then 2 into 3 would have meant 6, but we can see that we have used only 5 elements. In this case we needed only 5 elements, but one element would have gone wasted in matrix style. 2 into 3 means 6, but I wanted to use only 5, so I can use 5 using this way, while in matrix style 2 into 3 means 6 elements would have been there, and if I had specified 5, then one would have gone wasted. So I can simply use this concept of array of arrays which was given by Sun to utilize my space. So this was one main advantage. Now, studying about the example in this, we have a 3-dimensional array over here. Let me check if there is any other point related. No, right? So we have a 3-dimensional array over here. It means x is 3-dimensional array, and we are seeing that only the first square bracket contains the dimensions, so that it has to be all right. Of course, we are going to run this and see that all the things that we have discussed so far are right. So x0 means the first element of the 3-dimensional array. So first element of 3-dimensional array can point to 2-dimensional arrays, right? So we have given it creation of 2-dimensional arrays, right? So this is a 2-dimensional array. Now this 2-dimensional array can point to 1-dimensional array. So the element of the 2-dimensional array will be pointing to the first 1-dimensional only 1-dimensional array, I'm sorry. Then x00 will mean that the 2-dimensional array will be pointing to the first 1-dimensional array, and the second element is having this much of elements, and the third element will have this much of elements. Of course, these are all one-dimensional array. So to explain the point further, let's consider this figure. In this figure, we can see that we have declaration over here like this. So this is a creation of two elements, which has the capability of pointing to two-dimensional arrays, right? So we know that Sun has implemented array concept using array of arrays. So basically this is an array of array, and when we say that it has the capability of pointing to two-dimensional arrays, it means that the elements will go two steps down like this. So this is one array and this is one another array. So in this hierarchy we are seeing that the first element is pointing to the one-dimensional array, but actually it is going to three more arrays, right? Or we can go with more types of arrays over here, with more additions of the array elements over here, but the concept is to save the space. So basically this statement over here means this. In the first case, the Java compiler is going to create two spaces. Then in the second statement, x0 means the first element of this array, right? And the first element of this array can have or is capable of pointing to two-dimensional array. Because this is 3D, the first element of 3D is capable of pointing to a two-dimensional array, right? So the first element of 3D, which is x0 over here, is capable of pointing to a two-dimensional array, and we know that a two-dimensional array is capable of pointing to a one-dimensional array in this case and in the previous case. So new int 3 means it's going to have three 1D arrays, whereas 2 means it's going to have two 2D arrays, right? So the two 2D array is one is over here, the other one is over here. So this is x0 and this is x1. So x0 is given new int 3, it means it's going to have x00 equals to new int 1. This is according to the statements we have given in the example. So x00, it means this one will be having only 1, and this is perfectly an array because we can have an array with size 0. And then the second element, which is 0 1, will be having two elements of one-dimensional array. So two elements over here for x01, and in case of x02 we will have three elements of type one-dimensional array in this case, like we have represented. So if we come to the figure and try to solve these questions, x1 will be like new, we have to specify over here, then int we have to specify over here, and because this from the figure we can see that it is pointing to two one-dimensional array, it means the element or the size that we have to specify in the first square bracket is 2, right? For one thing. But in case of Java, say if we do not know the total number of one-dimensional arrays that are going to be represented, then the second brace can be left empty. So x1 equals to new int, and then instead of 3 over there we have to write a 2 over here in case of x1. So x1 equals to new int and then square brackets and then 2 and then another square brackets with no size inside that and then semicolon. So the answer should be x1 equals to new int 2, right? So new int 2, it means this is right. Then x1 0, it's going to point to one-dimensional array which contains two elements. So new int and 2, right? And x11 will be pointing to new int 2 once again. So this part being said, it's perfectly alright. Now coming to the last question of this session, let's see that we have a declaration of type this. Because there is no specification of size, this is a false statement. Okay, then we have another declaration over there, it contains all the syntax, so it is true. In case 3, again there is no size specification in the first square bracket, so it's false. We have a specification over here in this case, so this is true. Again, the first square bracket should not be left empty for size specification, and no matter if there is a size available in the second square bracket or not, so this is going to be false as well. And in the next question we have the size is available for all of them, so it's true. For this it is also true. For this we have a hierarchy where 3 and 4 are also available. because 3 is also fine over here, and then 3 will also be fine over there. So this is true. But in the next question we see that the square which is present in between is not having any kind of size, so we cannot do so. We have to give the size in a series, in an order. So we cannot left the middle square bracket and give size to the last square bracket like this. So this is false, and similarly this will also be false because we have to follow the hierarchy. So this is also false. So this ends the slide session for us, but let me quickly run the programs for you so that we can have a clarity of this situation. So let me run this program first, copying the code and once again going back to the test notepad and then pasting the code. And after pasting the code we can see that this is wrong. Alright, this is right. This is right. Okay, so this declaration is perfectly alright, where we can declare the first size and we can leave the next square bracket empty. Okay, if I try to remove the size from the first square bracket and try to provide it to the next one, then the code is not going to work fine. Let me just save it and run it once again to show you, and it's not working fine, right? So creating an array which is having reference of 2, some kind of error is going to come anyway. Next, move on to the next slide of 3-dimensional arrays. We try to copy the same code and then we'll try to run this inside the test case, saving the code and then trying to run once again, and we will see that there is no error. So this declaration is perfectly alright, but say if I try to move down and try to specify the size in between, then it's going to give an error as we have seen already. So 2, and then say I specify 3 as well, and then I try to run the program, I'll find an error over here. So it's wrong. If we try to have a declaration like this, then it should be perfectly alright because the symmetry is right. We have all the required sizes in order, so it's going to be working fine. It's fine, right? And then let's remove this one. Okay, and say I have a size over there and I do not have any kind of size over there, and then I try to recompile after saving the code and find an error again once again, right? So this being said, we have to notice one point over here is that no matter what kind of declaration I am having over here, say I have a 0 over there and again a 0 over here and again a 0 over there, so and I try to save the code, so there is no 1 present inside my code. There should not be a 1 inside the array like this. Okay, so it should give us an error. Let's see if this is giving any kind of error, and we can see that it's not giving any error. So basically Java, or in arrays Java is not responsible to check for the indexes, right? These are all indexes. Java is not responsible to check. It means if we pass the limit of the array, Java is still going to print the values, or Java is still going to run. That's why in advance we should know the size, and we should be very careful about the array processing. We should know that where our array ends and from where it begins, because Java is not going to take care of all those things, right? Say if I try to put an 11 over here and then I try to give it some value, it will be perfectly alright with Java to give it an 11. Say I have given it a 100 value, right? And I am giving x9 a value of say 109, right? And then I try to print. For now let's take to this code. It's not a good code related to Java, but for now take this code as x9. What we are trying to do, we are trying to print the number related to x9, and we have to print x11 as well, right? I have given 100 to x11 and I have given to 9. 11 is not the index related to 10 because the maximum possible index that can be given to the x is 9, because index starts from 0. So for 10 elements, the highest possible index is 9 and 10 is not there, so obviously 11 will not be there. So it should give us an error if we are not discussing right things over here. So let's compile it and see if it's giving an error. See, it's not giving an error. Now if I run this program, we'll find array index out of bounds 11 at test main, right? So 11 is not an index, so it's giving error to the 11th one. So at compile time it's not going to give any kind of error to you, again proving the point. So let's just remove this one and run once again, and we will see that there is no error related, and we again see that 11. Okay, we have not commented out this one, so let's comment out this one and then try to run the program once again, and it's running and it's working. 109 is printed onto the screen. So that's one way of printing or accessing elements of the array, as well as I have shown you like this. So this is something about creation and declaration of the array. In the next session we will be discussing about initialization of the array, and then initialization, creation and declaration in one line, and then there is something with the length versus length concept inside arrays. So thank you very much for listening. Keep watching and have a great day ahead. I hope my sessions are not boring you. So let's quickly close this session for now, and please comment on the videos so that I can improve the quality of the video related. Thank you very much.